Welcome to Dev Radio. We are getting ready for our next OpenAI hackathon. And today I've got Anthony and Yi with me. And we're going to start off with Anthony showing us sort of a real world example of using a semantic kernel in an application. It's not a production example, but it's a real app that does things. What do you got for us today, Anthony?
So I'm going to do a demo of a pet store built on AKS, leveraging some of our latest AKS technology, and we're going to integrate that into OpenAI. As Matt said, this is not a production deployment. Please do not clone this repo and put it into production. There are things that you shouldn't do, like don't use HTTP or use Key Vault as a way to store your secrets, not just put them into the YAML deployment. But this does a real thing, so we want to kind of showcase what that real thing does and stretch your imagination into ways that you could potentially leverage this application to grow and develop something. So I'm going to share my screen. Share screen. Everybody can see my screen?
Yep.
Outstanding. So this is my local fork of the AKS store demo. This is available at Azure Samples. But let's talk a little bit about what this does. This is a sample store application built on top of an AKS cluster made up of a polyglot set of services. So we've got Golang handling orders. We've got JavaScript in Vue sort of handling the front end. We've got Rust sort of doing CRUD operations. And we've got Python and OpenAI kind of handling the chat completion function. So there's two sort of user experiences in this application. There's the storefront where you as a customer would go, and there is a store admin section where you as an employee would create different pieces. This application can be run on AKS. It can also be ran locally. It can be ran on any sort of CNCF compliant flavor of Kubernetes. So feel free. I'm not going to take you guys through sort of the setup. Instead, I'm just going to kind of dive into what it looks like deployed. So here's sort of my solution in progress. Again, not a production app. Don't run a single node in your production environment. But we're up and running. You can sort of see that. We'll check out Container Insights really quickly and kind of make sure that everything is sort of lit up. Thinking. And look at that. I can see a load. I can see nodes. I can see my controllers up and running. And I can see kind of my container spawn. So for folks who are new to the AKS space, Azure has this very cool thing called Container Insights. This is just a very, very quick click through what Container Insights looks like, but easy way to get a sense of your cluster. So what does my application actually look like? So as mentioned, here's my storefront, not the most beautiful storefront by any stretch of the imagination. But we've got a variety of different pet products. So if I imagine I'm the owner of this pet store, I might think to myself, oh, I have this new product coming in. So my dog over there is Bella. Bella sometimes has really, really bad breath. But luckily for us, we've got a new product that's coming in, and that's going to be Bella's Breath Mints. So Bella's Breath Mints, price for that is $11.99. But how do I describe a breath mint for dogs? It's kind of hard, right? Like, Matt, help me out here. Like, what would you say about a breath mint for dogs? Like maybe dog, no stinky breath.
Yeah, fresh breath for dogs. Fresh.
What if there was an easier way to do this? Well, maybe I could ask an LLM. Look at that. So freshen up your furry friend's breath with Bella's Breath Mints. These delicious treats are specially formulated to eliminate stinky breath and leave your dog's mouth smelling fresh and clean. I love it. Let's save that product. So look at that. We've got Bella's Breath Mints stood up. So this was kind of a facetious example.
Yeah.
I don't imagine that somebody would build this, but when you talk about this construct of intelligent apps, there are ways to smooth out workflows that are common in your day-to-day application development lifecycle. So are you communicating with customers? And do you need a way to sort of structure an email or structure a response? Are you taking a look at long chunks of text and you need a way to summarize that or kind of get to the golden parts? Or maybe you're just owning a facetious pet store like I am, and you just want to figure out what to call Bella's Breath Mints. So how do we do that? We've heard all this stuff about LLM, about technologies, and the way that this works under the hood, sort of the OpenAI service that we mentioned, is this idea of a piece of technology you guys may have heard of, semantic kernel. So what is semantic kernel? As a software guy, when they initially said kernel, I was like, oh God, like, am I going to be having to, drop into C and do some hardcore stuff? But it's not that at all. Semantic kernel is just an SDK to help you do a couple of common practices or behaviors within the context of AI. So super high level, what are the couple of different functions that semantic kernel help with? They help with memory. So folks may know that OpenAI by default is stateless, meaning that every sort of conversation you send to it is a brand new conversation, but sometimes you need context to be able to make that stronger. Another big piece of the semantic kernel is this idea of a semantic function. So a semantic function or plugin is a way to kind of package a couple of different constructs together to make semantic kernel do a thing. But rather than talking to you about it, let me kind of show what I mean. So folks can still see my screen. This too small?
Yep. I'll zoom in a little bit.
Zoom. Where is Zoom in this? I never actually zoom on my monitor. Zoom? Where is my Zoom? Watch now as the guy fumbles around. Zoom in. Zoom in. Outstanding.
That's good. Yeah.
So this is the same repo that I kind of demoed in the beginning of this conversation, where we had the AI as a service. So here's sort of the README that we saw, but the place that I actually want to zoom in is inside the Python function, which is actually making the connection into the AI solution. So this is sort of the AI service. So at a really, really high level, this is just a fast API, Python API doing some basic stuff. But the important part is it's also bringing semantic kernel in. And so how do we do that? Well, like I said, kind of like, let's look at the code. So we see fast API coming in and sort of a basic health check inside our Docker file, kind of nothing magical here, just sort of Python running quick, easy, and done. When we look at our requirements, here we see semantic kernel referenced. And now let's kind of look at how semantic kernel gets used. So we've got our different pieces. Again, not a production example. Please do not put your API key inside environmental variables in your solution. But as we look at this generator, we've got sort of the functions to init it. We've got this class of product to sort of set up a description, and this is how that actual solution works. But to kind of click a little further, we talked about this idea of a semantic kernel skill or a function. What does that mean? What does it look like? Well, it's really, really simple. So the beginning of a skill is a JSON definition. So what are we creating? We're generating a description of a pet score product. We have a set of tokens that we specify. For folks that are unfamiliar, tokens are sort of pieces of word. So they're about 4 characters, give or take. So if you think about hamburger, hamburger is multiple sets of tokens cut up. We've got this function of temperature. Temperature is creativity. So when you have something that's a higher temperature, you make the OpenAI model get more creative, more abstract in its thinking. When you have a lower temperature, it's sort of more deterministic, meaning that it's kind of more literal. So the higher your temperature is, the more creative your solution has the ability to be. We then have this other sort of interesting variable called top P. Top P, when you are thinking about temperature, temperature is like the gradient of overall creativity. Top P is how close you are to, when you think about creativity, you think about words that are coming back from the AI. Top P narrows down the distribution of the word. So if you imagine with full top P or 1, with full top P, you have the sort of full scope and construct of all of the words in the OpenAI language. If you set a top P to like 10%, it would be the 10% closest words related to sort of the creativity. And then presence and frequency penalty are how likely you are to, presence is number of times a word appears more than one. Frequency is more than one. So if you want to make sure that your prompt isn't repeating itself over and over and over again, these are kind of the different variables that you can play with. There are best practice guides in terms of temperature, top P, presence, and frequency that help you create different AI experiences. So that might be something like a conversational chatbot versus sort of like an FAQ solution. So these things can be tuned to help yourself. Other piece of this is, what are you going to take as an input to help and generate something? So this is where this input name and parameter piece comes in. So when we fed something into the generative AI to create something, we gave it the name and we gave it the tags that we included. So how does that then come together? Go ahead.
Do you mind further zooming in? Still,
Oh, sure.
the font is size as well as
Zoom. How's that?
much better. Thank you.
Outstanding. So now we actually look at the prompt, and this is the other half of what that structure looks like. So first we have a set of rules. These are the rules that we fed the prompt. So don't waste words, don't use bullet points, no profanity, family safe. You can ban phrases. So if there's specific pieces that you want to make sure that you don't use, so don't say this product in the product name as an example. And then finally, you give a couple of examples of how the solution should look. So here's an example of Mermaid's Mice Trio. Here's an example of Anchor's Away Chew Toy. And then finally, you parameterize, describe the following product, given name and given tag. And this is sort of where all that magic comes together with a end-to-end prompt. So this is literally everything that happened to create that auto generation piece by taking semantic kernel and applying it inside an application, inside Python, in a larger Polygon app for AKS. So yeah,
super helpful. Cool. We'll get the link to the repo where people can find this code and play with it into the description. And
outstanding. So a couple of calls to action for folks. I think as Matt said at the top of this call, we have a variety of sessions coming up with hackathons, etc. This was meant to show that this isn't scary or overwhelming. It's a little bit of code. There's a little bit of repos. And this is a way to sort of dive in and get your hands dirty doing something real. While my pet store needs some work to be productionalized, it is actually a pet store. And we did genuinely develop something that comes together pretty quickly.
Yeah.
Last call to action, there is an awesome semantic kernel free course on LinkedIn Learning that does a way better job of getting into the nuts and bolts. This will give you enough to get started, but strong recommendation to check that out.
Cool. Great tip.
Yeah. I actually took that course 2 weekends ago. It was wonderful, which made me feel I need to prepare for a more comprehensive semantic kernel session, knowing that it's gaining popularity and traction. More and more customers are asking about it. They wanted to learn more about it. And then for large language model, like as an OpenAI service, fundamentally, they understand the language. It's like if we were to use analogy of a human body, large language model might be the brain, our ears, or our mouth. But we need other components to take actions. This is where semantic kernel come into play to have we predefine some functions, and then when the prompt request comes in from the end user, the large language model will first try to understand the ask, and then based on the description of each of the predefined function, it can automatically identify which functions we might need, and then in which order we want to run those functions in order to achieve the goal, in order to provide the desired response to the end user. So it's very, very powerful.
Yeah, great description.
The way that I think about it is if each of these pieces are Lego blocks, semantic kernel is sort of the instruction manual that tells you how to build the spaceship. The other thing that I'll call out, which we get asked a lot, is should it be semantic kernel or should I look at LangChain? What are the pros and cons? We can definitely do a deeper dive session on that, but at a high level, I'd tell you this is a Coke versus Pepsi question. They are both awesome solutions with sort of different nuances back and forth, but the underlying structure of orchestrating two large language models works in both dimensions. So don't get caught up on should I have a Coke or should I have a Pepsi? What do I do to get started? My advice is just get started. You might build a pet store.
Yeah. Cool. Awesome. Thanks so much. And we will be back to talk with both of you about a few other related topics in the next videos. So thanks so much.
Thank you.